All right, 6.1, radical expressions and functions. So we want to talk about what a radical is, what all it involves, and all of those types of things in this chapter. Okay, so let's define a few things. All right, our first definition, C is a square root. So those are our kind of phrases there of A if C squared equals A. Okay, so kind of a different approach to how we think of square roots. We usually think of that symbol, but really to know what it is, anything that we can square to create that A, what we squared, what is a square root. So we could have multiple square roots if that's possible. So we're going to look at some of those items in just a moment. Okay. Second definition here, radical expression. All right, and this is anything in the form of the kth root of A. Okay, the kth root of A. Now, a few things there that we do need to denote on these. Here, this is called the index, also known as the root. That's another term we use for that. I'll typically probably say the root there for that. The little piece that most people call the square root symbol is not actually a square root symbol. The square is the root for that, for those pieces, but that is called a radical. And then underneath this is called the radicand. And we don't use that phrase very often, but that is the official math term for whatever's underneath our radical there for those, okay? And so as you heard me say, this is called the kth root of A. That's how we want to read that for those, all right? So we want to pay attention to how we read and write all of our stuff when we're doing those, all right? All right, we have one more definition here. It's actually a two-parter, so part A and part B. If K is even, then the kth root of A to the K equals the absolute value of A. And we'll talk more about that in just a moment, okay? But if K is odd, then the kth root of A to the K is just A with those. It's kind of like the root and the power cancel each other out there in that case. But again, we'll talk more to why that is in our examples so that we can kind of see those things, okay? All right, so let's look at our examples here. The first one is find all square roots. Okay. So number one, 16. Okay. So when we think about square roots, usually we use that square root symbol here. We're not going to do that. We're just going to do that. What multiplies by itself to give me 16? And the obvious one is 4. Okay, most people can say 4 times 4 does equal a positive 16. But we actually have a second one, and that is negative 4. So negative 4 as well. Negative 4 times negative 4 gives me a positive 16. So therefore, negative 4 is a square root of 16 for those. Okay, and so we got to be careful with that. If I'm talking about all possible square roots, then we need to list out both the positive and negative. So another example of that would be if we looked at 25. Okay, so we know that for 25, we would get positive 5 and then negative 5 in that case. So we'll recognize those bits and pieces there for that. Okay. Now we don't ask that question a whole lot, but we do need to know that for math of later on pieces. We're going to talk about some certain formulas, and we got to make sure we recognize where parts of those come from. And part of that is recognizing all the square roots. Okay. All right, so now we just want to simplify. Okay. So number one, here, if I have just radical and then 81, we do call that the square root, okay, with that. So meaning 2. Our index is 2. We use it so often that we don't put it there. So if there's not one listed, it is a given 2 as my index, okay? So we want to always remember that with those, and we can call it the square root in that case. So I'm going to take that back off because we know that that's supposed to be there for those. Now, when I have the radical on this, my answer is not the all square roots. It is, what if I plug this into my calculator? What is the single answer it gets out? It's for those, okay? So here, the square root of 81, we know is 9 for those pieces. You can do that on your calculator. If you don't know that, I do recommend that you just memorize up to probably about 144, meaning 12. Square root of 144 is 12. So you need to know what 1 squared, 2 squared, 3 squared, all the way up to probably 12 squared. I even recommend 15. That's what I have memorized up to. That would just make your life a little easier, but you're not required to do that. Your calculators will do it for you. If you need help with putting things into your calculator, please just let me know so that we can talk about it, okay? I can show you how to do that. All right, so I'm going to do just a few of them real quick for these. So the square root of 169 here is 13. I'm just going to do these all the same. They're real fast. It's just pure calculator work in those cases. All right, negative square root of 121 for these. So that's going to be negative 11. So the square root of the 121 is the 11, and then the negative just comes on in front. Okay. Square root of 49 over 36. Well, we can actually break those apart. Just take the square root of each one. We'll learn that official formula later on. The square root of 49 is 7. Square root of 36 is 6. So we get 7 over 6. Oh. All right, number 5. Square root of negative 64. Okay. So for this one, we try to find two numbers that multiply together to give me a negative 64. That does not exist because they have to be the exact same number, right? It's a single answer that we're getting. 8 times 8 is a positive 64. Negative 8 times negative 8 is a positive 64. So for square roots, and we'll find any evens, 2, 4, 6, 8, 10. If my index is even, then we cannot do it. This is not a real number. Now, in another unit, we're going to go to a new number system where we can do those, and we'll talk about those. But for now, we would just say not a real number as our answer, right? So pay attention to that. All right, third root of 27. Okay, so we've talked about those third roots before. So we can do those now, but again, if you're struggling with putting those in your calculator, please get with me so that we can get that figured out as soon as possible so that you know how to find those third roots. And we should hopefully remember that's 3 because it's 3 times 3 times 3. Make sure you're putting in the right things into the calculator so that you're getting the correct answers. The third root of negative 125. Now, because 3 is an odd, we can do negatives. All right, so a negative 5 times a negative 5 times a negative 5 does give me 125. So we don't have a problems with negatives when we have an odd root, meaning 3, 5, 7 for those types of things. So feel free, you can do those. We can get an answer there. So pay attention. Is it odd? We can do, or even we cannot. All right, negative third root of negative 8. And here we want to be careful. We've got a lot of negatives going on. So I'm going to break this one apart. This is negative. Well, the third root of -8 is a -2, and negative times negative makes a +2 for that one. Okay. So we want to be very careful there. Number 9, the fourth root of 16. So again, a lot of calculator work here. If you memorize a few of them, you may figure this one out pretty quickly. But this one is going to be 2. It's 2 times 2 times 2 times 2. See, I did it 4 times there. Give me 16 for that one. The fourth root of -81. Again, this is an even, so that is not a real number. Cannot do it. There's a negative under the radical, and we have an even root. Doesn't matter what size it is. All right. The fifth root of 32, we would see as well too. Again, all of these are calculator work, just trying to show examples of things. And then if we had the fifth root of -1, well, it's an odd, so we can do negatives, and it is -1. 1 is its own root, no matter what the number is, so we can always do a 1. Okay. Number 13, the square root of 16x squared. All right. Now we have a couple of things going on there, right? We've got a 16. We know we can take the square root of it. We've done that already. But then we've also got this x squared. We've got to think through what we do with that. So I'm actually going to break this one apart. I want to look at them. There's a rule that says that we can do this. It says square root of 16 times the square root of x squared. Now, if we remember on this, that's a little 2 out there, right? And so we can think about those pieces. Let's go ahead and do the square root of 16. That's 4. Excuse me. I knew that sneeze was coming. All right. So here, these are the same, right? And if we go back to our definitions, we had a definition that said if our power and our root are the same, then some things happen. Now we have to look, is it an even or is it an odd? In this case, it's even. So since they're even, my result is what we're taking the square and square root of, which is x in this case, and it goes back in an absolute value. Now, the reason why it needs to be an absolute value is because we don't know what x is right now. We don't know if it's positive or negative. So if it were negative, if I were just to put x there, then it comes out as a negative number. But we've already said for even roots that we cannot get a negative out. Now, the reason why it wouldn't be negative here is say this square is going to make it positive. That's a negative times a negative makes it a positive. And then I take a square root of the positive result. So we have to follow the order that it's put into. So make sure that we get that positive result. That's what the absolute value bars are for. Because absolute value means everything is going to come out positive for those. Okay? And that is our answer. All right, now what if we have square root -12c squared? Now, there's a couple of different ways. I'm going to go ahead and work this completely out so that we can see the pieces to it and not get too confused here on those, okay? So when we square a parentheses, we square everything inside. And so we're going to get the square root. Well, -12 squared is a positive 144. And then c squared is c squared. So now we can break those things up. So the square root of 144 is 12. And because this is even, we're going to get the absolute value of c for those. Okay. So we, working that out and then bringing it back together, we get to the same place. Now, another option for this, so I'm going to put right here option 2, is that we can just simply say here, because these power and the root are the same, that we can do the absolute value of negative 12c. Well, the absolute value of negative 12 is a positive 12. The absolute value of c is I don't know. And so we end up with the same result in the same amount of steps here for those, okay? So we can see that for those pieces. So either one of those ways would work when you're doing this problem. Okay. Third root of 8x to the third. Now again, I'm going to go ahead because it's a new root. We're going to break that apart. So third root of 8 times the third root of x to the third for those. That is some messy handwriting. So I'm going to rewrite that just simply because I did not like the way it turned out. Okay, that's a little bit better for those. Now, earlier we looked, the third root of 8 is 2. Now here, these are going to cancel. This time they're odd, so we don't need the absolute value. We can get negative numbers for those, as we saw before. So our answer here is just 2x. Okay? So you got to pay attention. Do I have an even or an odd? That way I know whether I need my absolute value or not. Okay? All right. You will be asked to find the values, but at this point, we should be able to plug those in and work that out. Follow your order of operations. You have to do what's inside first. So make sure you're paying attention to those details for those. I'm not going to work any of those out because you should know how to do that. You should be able to plug into X at this point and simplify for those things. Your calculator will do a lot of that work. Remember that if you were to show one of those on an exam, you need to show plugging in. You need to be able to then work it out afterwards. Okay, but at minimum, show what you're plugging in. Last thing though, we're going to find the domain. And so if we have this function, f of x equals the square root of 5x minus 10. Now we're going to focus on square roots because that's what we use the most for these. When we're paying attention to those pieces, all right? So here, when we're looking for our domain, the one thing for a square root we cannot have underneath the radical is negatives. We cannot take the square root of a negative, okay? So we need to figure out where is this negative, and we want to take that out of our domain, okay? Now to do that, what we're going to do is we're going to take what's inside the radical, 5x minus 10. And we don't want it to be negative, which means we want it to be positive, but it can also be 0. 0 is not a problem. We can take the square root of 0 because that's 0. So as long as it is positive or 0, we're good, which means that we want to be greater than or equal to 0. Greater than 0 is positive, equal to 0 is 0. And then we solve for our x here, okay? So we solve the same way. We're going to add the 10 over. So 5x is greater than or equal to 10. And then we divide by 5. So x is greater than or equal to 2. Okay. So you may need to write it in this. This is called inequality. Inequality notation. Or if they want it in interval notation. So interval notation. This is greater than 2, so that means it goes from 2 to infinity. So 2 to infinity. Remember that I put the bracket because there's an equal sign. All of these problems, the number will have a bracket, and the infinity will have a parentheses. Okay. All right, let's do one more of those before we're done here today. So number 2, g of x equals 3x, square root of 3x plus 4. So again, we're going to take what's inside here. So 3x plus 4 is greater than or equal to 0. So we're going to subtract the 4 over. We're going to get 3x is greater than or equal to negative 4. And then divide, x is greater than or equal to negative 4/3. And it's okay that that answer is negative. That is just the starting point. If I plug in negative 4/3 here, I'm going to get 0 out. So everything bigger than that is what we want, okay? So again, that is our inequality, or we would say negative 4/3 to infinity for that one. Okay, so based on however they want their answer, that's what you're going to be looking for in those cases. Okay. All right, so that is how we open up with radicals. We're going to be dealing with a lot of things here on radicals, simplifying and working with those. So make sure you know how to do those basic pieces.